Now look at this.
What's up, penguins? Today we're going to do topic 6.2 on replication. So real quick, let's talk about DNA. So DNA is going to be anti-parallel. So the two strands are going to be equidistant from each other. So that's why they're parallel. And then they're anti-parallel because they're going to move in opposite directions. So at the 3' end, we have a hydroxyl group, and the 5' end, I have a phosphate group. It's important to note that DNA, in terms of replication, is always going to read 3' to 5'. So it's going to read the strand that has the hydroxyl group to the phosphate group, and it's going to synthesize the new strand 5' to 3' because it's anti-parallel. So replication is going to involve a lot of different enzymes and different players in the process. So let's first talk about helicase. Helicase's job is to break the hydrogen bonds between that double strand. And so if I've got my two strands together, helicase is going to break those hydrogen bonds, so it pulls them apart. The second enzyme we need to talk about is DNA polymerase. DNA polymerase, as the name says, is going to make the DNA polymer. Its job for synthesizing the new DNA strand. The thing is that DNA polymerase can't build off of nothing. So just like a crystal needs to have a grain of sand, DNA polymerase needs to have a primer to build off of. And so that's where our third enzyme comes into play. Primase is going to synthesize the RNA primers, about 5 to 10 RNA nucleotides that will allow for the DNA polymerase to build off to synthesize the new strand. So our fourth enzyme we need to talk about is top isomerase. So shout out to Dr. Gleason at Georgia College and State. So helicase, we already said, was going to unravel and kind of like break the double strand. So if you notice, as I break apart these two strands, it's going to get super coiled. So the job of top isomerase is to relieve that strain upstream. And so it makes it so that the DNA doesn't get super coiled. So now that we've talked about all these enzymes, let's talk about DNA replication. So DNA replication, there's two different strands we have. You have your leading strand and you have your lagging strand. The leading strand is going to move continuously toward the replication fork, while the lagging strand is going to move discontinuously away from the replication fork. Miss Jones, what are you talking about? So helicase is going to pull apart the two strands. So the one that moves toward the part that's being pulled apart, that's your leading strand. And I say continuous because it never has to stop. It just keeps on moving toward the fork because as the DNA polymerase moves toward the fork, helicase keeps opening and it keeeps finding more and more DNA to move into. Whereas the lagging strand, it can only move this amount, then it can only move that amount, and it only move a little bit at a time. So it's going to keep kind of releasing and jumping back. So it's considered discontinuous. Last enzyme, DNA ligase, is going to seal the ocosecond fibrils and lagging strand together, so we have one continuous strand. Don't forget to hit that follow button. AP Bio Pay and just bye y'all.